Assalamu alaikum and good afternoon, dear scholars. So we continue of our presentation in developing of Uzbek stemmer. So we chose Loving stemmer as a base model of developing the Uzbek stemmer. So we have added some functionalities. This is our proposed model, which has two approaches. First one is a dictionary checkup approach. In this approach, we have a set of root words that is already stored in the database, and we have a second approach called affix stripping approach. We define a number of affixes in Uzbek stemmer that will be applied to affix stripping approach. So let's see the flowchart of Uzbek stemmer. So flowchart starts with getting the input from the user. Then after the user enters the input, Uzbek stemmer will tokenize the input text, and next step is the first approach of Uzbek stemmer, which is comparing each input word with a database stem, and if input word match with the database stem, then it will just remove the affixes from the input word. Then remaining part will be displayed as a output, which is stem. Okay, if input word doesn't match with the database stem word, then it will go to the next approach, which is affix stripping approach. So as we said, that we have predefined affixes in the Uzbek stemmer. So in this step, Uzbek stemmer will check each input whether it has predefined affixes in it. If input word has affixes, then Uzbek stemmer will remove the affixes, and the remaining part will be displayed as a output stem, result of Uzbek stemmer, result of the stemmer. Alright, if input word doesn't match with the database stem word and it doesn't have any predefined affixes, then Uzbek stemmer will display this word as an invalid word. Okay, we have prepared our lexicon using Uzbek dictionary. And we have more than 14,000 stem words that is stored in the database, and we have a list of affixes that is defined in the Uzbek stemmer. As you can see on the right table, we have 5 prefixes and 27 suffixes that are already predefined in the Uzbek stemmer. And from the left table, you can see the combination of stem and affixes. Let's see the first word, which is bola. It means child, and it's a noun. If we add m suffixes to bola stem, it becomes bolam, means my child. So this is an example of Uzbek root word and Uzbek affixes that is attached to the root word. So implementation is done using Python programming language, and for the database purpose we use MySQL database management system, and Uzbek stemmer is available as a website using this stemming.uz domain. So anybody who is interested can explore Uzbek stemmer using this stemming.uz domain. So this is a user interface of Uzbek stemmer. In first column, in the first input, user have to put the original input word, and after clicking this stemmer topish button, second input will show the result of the stemming process. From the screen you can see that we have entered Vatanam, and from the second input you can see the output, which is stem of the Vatanam word is Vatan, means country. If you add I am Vatanam, it becomes my country. Okay. So for the evaluation purpose, we have prepared 3 datasets that contains more than 4,000 words, and evaluation is calculated or measured by applying the compression performance formula. This is a compression performance formula, which is C is a compression ratio, and W stands for number of unique words before stemming process, and S is number of unique stem words after the stemming process. So let's see our result. So we have tested using these 3 datasets, and first dataset gave us 48.7 compression ratio, and second dataset gave us 29.73% compression ratio, and third dataset produced 37.53% compression ratio. So we can conclude that in this case Uzbek stemmer is performed from 29 to 48% compression ratio. So we can compare this compression performance with most famous English stemmers, which is Lowens, Porters, and Pace and Husk stemmers. So from this table, we can say that Uzbek stemmer is performed better than Porter's stemmer, and Uzbek stemmer also performed very close to Lowens stemmer, and Uzbek stemmer produces lower than the Pace and Husk stemmer, which is still good performance. As a conclusion, we can say that this Uzbek stemming algorithm is one of the first stemming algorithm that has developed for Uzbek language. An advantage of Uzbek stemmer is it produces high accurate results, and weakness is Uzbek stemmer may reject valid Uzbek words if the input word is outside the lexicon and it does not have any affixes that is predefined in the Uzbek stemmer. And this Uzbek stemmer algorithm can be applied for other Turkish family languages such as Uyghur, Turkmen, or Kazakh languages. These languages have similarities in terms of morphological form. However, depending on the language, algorithm may have some changes. Alright, thank you for your attention.